success is having the right coach. Get the best education with Parvathy Thejus and make your GCC and government exams dreams come true. Download the app now.
Welcome back to my channel. ഏവർക്കും എൻ്റെ ചാനലിലേക്ക് സ്വാഗതം. So today we are going to begin a new session and we'll be discussing some of the PSC questions asked for Radiographer's exam. And these questions are I have taken from the PSC bank, and we'll be discussing a few of the PSC questions for the upcoming weeks. So this is a part 1 session for PSC Radiographer. Moving on to the first question. Apoptosis, which is a programmed cell death, is most important in option A, lymphocytes, option B, sarcomas, option C, carcinomas, and option D, all of the above. The answer is option A, lymphocytes. So now let's see the explanation. Apoptosis occurs normally during development and aging as a hemostatic mechanism to maintain cell population in tissues. Apoptosis also occurs as a defense mechanism, such as in immune reactions or when cells are damaged by disease or noxious agents. Moving on to the next question, question number 2. The following is true with respect to cell loss factor. Option A, the fraction of cells produced by cell division loss from a tumor. Option B, large for carcinoma. Option C, small for sarcomas. And option D, all of the above. So the following is true with respect to cell loss factor. The answer is option D, all of the above. So the fraction of cells produced by cell division loss from a tumor, large for carcinomas, small for sarcomas. So now let's see the explanation. Cell loss in a tumor is recognized by the presence of individual cell death, massive or focal necrosis, and or explosion of cells from the tumor mass. The cell loss factor represents the rate of cell loss as a fraction of the rate at which the cells are added to the total population by mitosis. Now let's see the third question. The following is not true in relation to late effects. Option A, overall treatment time determine the response. Option B, the fraction alpha by beta is about 3 gray. Option C, fraction size is a dominant factor. And option D, none of the above. So which of the following is not true in relation to late effects? The answer is option A, overall treatment time determine the response. Now let's see the explanation. The percentage of people in a study or a treatment group who have a partial or complete response to a treatment within a certain period of time. A partial response is a decrease in the size of the tumor or in the amount of cancer in the body, and a complete response is the disappearance of all signs of cancer in the tumor. In a clinical trial, measuring the overall response rate is the one way to see how well a treatment works, and also called ORR. Moving on to the fourth question. The following is not true for hyperfractionation. Option A, improves local tumor control. Option B, no increase in acute effects. Option C, no increase in late effects. And option D, increase in late effects. So the answer is option D, increase in late effects. So which of the following is not true for hyperfractionation is increase in late effects. Now let's see the explanation. Radiation treatment in which The total dose of radiation is divided into small doses and treatments are given more than once a day. Hyperfractionated radiotherapy is given over a same period of time, that is days or weeks, as standard radiation therapy, also called superfractionated radiation therapy. Moving on to the next question, question number 5. Example of an indirectly ionizing radiation is option A electrons, option B neutrons, option C alpha particles, and option D protons. The answer is option B neutrons. So now let's see the next question, question number 6. Neutrons are indirectly ionizing in tissue. They give up their energy and do not produce. Option A recoil protons, option B alpha particles, option C secondary electrons, and option D heavier nuclear fragments. The answer is option C secondary electrons. So now let's see the explanation. Neutrons are indirectly ionizing. It is not neutron itself that strips the electrons of the target atom. Rather, it is something the neutron has produced. So the example for indirectly ionizing radiation is neutrons. So moving on to the next question, question number 7. Neutrons and X-ray are similar in the following way. Option A, value of oxygen enhancement ratio. Option B, both are indirectly ionizing. Option C, sensitivity through the cell cycle. And option D, repair of sublethal damage or potentially lethal damage. The answer is option B, both are indirectly ionizing. So the neutrons and X-rays are similar in the way that both are indirectly ionizing. Moving on to the explanation, X-rays, gamma rays, they do not produce chemical and biological damage themselves. They give up their energy to produce fast-moving charged particles that in turn are able to deposit their energy and produce damage. Moving on to the next question, question number 8. The following is an example of densely ionizing radiation. Option A X-ray, option B gamma rays, option C alpha rays, option D electrons. The answer is option C alpha rays. So, an example for densely ionizing radiation is alpha rays. Now let's see the explanation. Densely ionizing radiation such as heavy ions produce biological damage which is different from that normally produced by sparsely ionizing radiation such as the X-ray or the gamma rays, which are a large component of a natural radiation background. Question number 9. The characteristics of a cell survival curve does not include option A, the extrapolation number n, option B, Cauchy threshold dose dq, option C, mean lethal dose d0, and option D, linear energy transfer LET. The answer is option D, linear energy transfer LET. Now let's see the explanation. A cell survival curve is a curve used in radiobiology. It depicts the relationship between the fraction of cells retaining their productive integrity and the absorbed dose of radiation. Conventionally, the surviving fraction is depicted on a logarithmic scale and it is plotted on the y-axis against dose on the x-axis. Moving on to the question number 10. What is the relationship of LET and biologic damage? Option A. They increase in direct proportion. Option B. They are inversely proportional. Option C. There is no relationship. And option D. There is non-linear, non-threshold relationship. The answer is option A. They increase in direct proportion. Now let's see the explanation. LET, linear energy transfer, RB, relative biological effectiveness, and OER, oxygen enhancement ratio, are important terms in radiobiology and relate to the relative damage that will occur with radiation under different circumstances. So these all are the factors in radiobiology which relates to the relative damage that occurs with radiation. So as LET, that means the linear energy transfer increases, there are more energetic electrons deposited closely together and thus damage to DNA is more likely. Therefore, even with the same radiation dose, a high LET radiation will cause more damage. X-ray are low LET, that is low linear energy transfer. Alpha particles and neutrons are high LET. So the RB is the measure of the damage that will occur in comparison with X-ray for the same radiation dose, and high LET radiation will have high RB. RB means relative biological effectiveness. So as LET increases, RB also increases. Oxygen enhancement ratio means what? It is the ratio of the radiation dose needed to cause the same biological damage when there is oxygen present to when there is oxygen present and absent. So oxygen enhancement ratio means what? It is a ratio of the radiation dose needed to cause the same biological damage when there is oxygen absent to and when there is oxygen present. So with that, I'm winding up today's session. Hope today's session is clear. And in the upcoming sessions also, we will be discussing more of the PSC questions for radiographers exam. So stay tuned till next Sunday. Sunday is the day I used to upload new videos. So until then, stay safe, stay healthy, and stay tuned for my next upload. Until then, bye-bye.